is wherever you are. All right, let's see. We actually did that. We pretty much did all this. Did a little bit of investigation on this stuff. On the Lambda end, you can sort of do... You can do tags, 2 versions, and have a stage variable that refers to a tag. There's a little bit of trouble with giving permission to the tags, but once they're set up, it's not too bad. So actually similar to this, we're going to want to do probably some core setup, CDN. Well, I guess CDN is more of a deployment thing. Basic extension function, and then we have to switch URLs over to CDN. Everything might be kind of solved. So where did we leave off? Okay, that's just notes. Okay, so that's what we did before. Right, we moved a bunch of stuff up to main update. So we're starting to get this to look a little bit more like a standard Elm map. And I wanted to see if we can generalize at least the HTTP requests. I don't know about the rest of this stuff. So these are doing some case-specific decoding. So if we could kind of pull this out into what you would normally think of as your like kind of tagger to message, then you'd have a better grounds to abstract that to something. So a bunch of these have to do state decodes. And it's all just decode state. The one reason we can't do that at this top level event here is because on our very, very first thing, it's something else. Unfortunately, that something else is just a JSON value, so you can't easily use a one of, and you still have to do a case if there was a one of, so because you could have 2 different responses. I guess if I had like a separate little function for HTTP response. Well, you don't necessarily have direct state. What do I pass as state? Oh, you actually get a null. So that wouldn't decode. Alright, so this is a response decoder. So we've got JSON, we're passing it to decode value, so it's kind of, well, I guess we could actually say, well, if this was variable, you could do a variable thing. There's some transformation going on here because it's like this would be like your ordinary decoder. The errors. Well, I guess fetch videos could be legitimately blank. But that would be legitimately blank, not error. So that would get translated to some kind of body error in if we were like more fully abstracting HTTP stuff. So what we want is a system where we would, well, we've got the code token, we've got decode videos, we've got Helix users. A bunch of these need to decode state. And then that gets passed on down. Well, the state would actually be, arguably the state would be closured in to the response if you cared about the state. And you had made the call with a particular response, which would argue for doing an argument swap on those. I think I was looking at it as, well, okay, so you're gonna, I know this is the ultimate response, which would argue for swapping that kind of on everything. Where we've got that. And then that would be a way to tag which thing this response went to. I think the string argument HTTP error is very similar in that sense. It's a thing you curry in to say, what was this? Okay, so that yeah, all of that. I don't think anything there would have been type compatible with the argument it swapped with. So that should be fine. That would actually sort of solve the decode state problem, if you were able to generalize it. Could we generalize? Well, you're doing an update with blah, 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 blah. So our HTTP error right now is a Lambda HTTP error. Which does not include the body condition. So maybe I also have to have a type, my local type, that's HTTP error, where everything translates one-to-one. And we can have, like, bad body. Oh, we've got, well, what's the bad body? Oh, that bad, okay, so we've already got a bad body, but it's a bad body string. This would be a bad body value. With no way to make it a... There's no way to turn that back into a string. So maybe bad body isn't the right word then. Although probably decode error is one of the main things you would get from there. Now, I could go back to passing the body as a string and do all decoding on this end. Then it would go from decode value to decode string. You wouldn't have a bad body at all. Oh, this is Lambda. I mean, actually, it's index. State, info tag, underlying error. Right, so for certain conditions, or some errors will return a body. So we can catch this back here. Or we could just return it as a string. It's like it's doing less work in one place. And I think in the long run, that lets us to have more centralized management of the reasons the body could be bad. So there is no bad body. Wait, I did some stuff. It's very trivial stuff, but... So this is essentially a result now. It's either a success or an error. Well, having some room in there might be nice. So you don't have a bad body. And there was no special case for that on the other end. So now this can have your... I probably haven't imported the entire thing. Or I could change that. Oh, you're going to be a string now. Oh, and yeah, actually, that is not just a drop-in replacement because type's changed, but that's all port boundary stuff. State value. Wait, that's the code token. Fetch token might be doing that. State value, state value. The state for event. No, the event's still coming as a value. So you're not a JSON. And all these are JSONs, so all of these are body. Which means you probably are going to be decode string. Okay, right, and that changes the decoders. And do I have a type for my response? Yes, I do. Okay, that all seems to be good. So we're going to have something like this. Can I parse that as anything? Yeah, I can't do a generic string to value translation. So if you know what kind of error messages you expect, you could do something with that. Well, if I need to debug something, I will be able to go in and intercept the value before we try to decode it. So got token's going to come back with that. I think this, we want to translate it. And we can only translate Lambda errors to HTTP errors in one way right now. All right, so that was the Lambda error. Don't know what to call these. This is unfortunately just kind of an annoying one to write. Bad status. Status body. Lambda. And those are the only two cases of Lambda error. Okay. And actually, update HTTP error. My error. That's sort of, well, that gives me a place where we could do bad status specifically that. So we could actually translate that into like an authentication failed error, since that's the specific case we want to deal with. I'd probably still have to do the model updates here. We need the state. That could be done at the other end. Oh, no, HTTP errors still have state and source. It's really a wash where we do that. So what we've done here is we have made our own error type where we can now deal with the decode errors here. So this is going to be, we have a result of decode and we do two different things. Now, does HTTP error still involves decoding state? So maybe I actually pull the type of message out with the variable. Then we have something to look up the decoder for that. And that's where we'd actually kind of end up. That would kind of be a maybe thing. I guess we just return a decode.error. Now you see, this is almost. You could do kind of a decode.and then type thing. Well, we can still do a decode.fail given on a regular old function. All right, so that gets the body value. It doesn't really do anything with it yet. So that's the general form of that. We have to do two decodes. So we can have an unparsable state, we can have an unparsable response. We could have both. So either both are bad, one is bad, one is bad. Could unparsable state be our own HTTP error? That would be one way to handle it. We've got all these debug to-dos right now, which, I mean, admittedly, that is a really fundamental error. I mean, I could probably just dump that error where it is. There's nothing I can really respond to there. So actually, that is itself a code change. So that becomes... Oh, except this is supposed to return a HTTP error is supposed to provide a state, so you can't do that. I mean, I can provide a null. No, actually, state is a structure. And I went ahead and made HTTP error message return a state. So that can only handle successful things. Okay. So I have two things that can be JSON errors. I'm trying to decide if I want to do the two tuple case statement, if like both failed, or just like do one then the other. Yeah, so here's the awkward thing. We could sort of like build up a partial value here. So I swap the arguments on the idea that this would sort of be doing this, because this is sort of like, this is specific to the message and this is specific to the message. And this kind of ends up in the middle for the moment. Actually, in theory, our state may also be able to tell us what we're expecting next, in terms of which decoder we're going to try. It wouldn't actually have any relation to this. So we get a decoder, we try to decode it. That might actually be a little bit of a better match for what our eventual process is going to look like in terms of if we're going to be managing state elsewhere. So then you are... I know, we're just going to have something like this. I guess this could just be a function because there might be a decoder for. We could just have a function for it. Oh, but this message also depends on that. So then we have case tag. We've still got a special case for you. Actually, are you that special? You don't decode a state, and indeed state would be invalid for there, which we would eventually solve by what we pass here. So this washed out the result. Oh, no, we do have to do this as a separate step. Yes, this is a double decode, or double case. Because we've got, do this for now. Result equals and it's just a straight up result at that point. And then we have to depend on that, which could probably just become inline. Oh. He's going to decode variable types. I don't know if I can handle this in one place. Elm might not be able to handle the type ambiguity here. It could probably handle it on a case-by-case basis. Which means we have to do this first. And then in each of these, we're going to have to do okay, caps lock. Now decoder 4. given a string, we return... Yeah, you can't do that. Because they're going to be decoders of different types. Does this mean a generic HTTP handler is impossible? So the main Elm library has an HTTP request that has an expect, which has a type, which is going to match any types that are in the message. So in that case, you've already got like this expression has a function you apply, which is of a certain type. It's the type you pass on down if it's successful. But you can't write a function that returns that variable decoder. Actually, for that matter, you can't store. I've been thinking eventually you want to get to a point where we could store HTTP requests in some level of Elm. So that's the only type I'm producing a message. So maybe the string switch has to handle everything. So we'd have to pass the state through that. And that's where the argument order is actually going to hurt me for a little while. Because as long as this thing results in a message, we're okay. But you can't do this decoder for, we're already in fetch videos. We already know what our decoder is. Because we swapped that around. So this is just decode videos. So in this expression, we know what that type is. HTTP error, and HTTP error took. Our state, the tag, which we just have variable. That was mapping it from a Lambda error, so this is a bad body. And then we have to handle all other strings. Which we previously handled down here. It's probably going to tell me that the cases aren't right. Oh. Well, I guess actually we can do this, and then we still got tag and scope there. Previous pattern, yeah. So this ended up being too generic. So how about, and this handles unknown response. It will never get there because we're handling this up above, but it should cover this case. And I think I have a generic error catch case. All right, so we need a Helix users fetch user by ID. Which gives us a got users by ID. And I might be able to make a function out of this. All right, videos with name. Actually, that would be, maybe I wasn't actually using the other bare videos case. Because that one would just be videos. Well, maybe it runs through that request. I'd have to, okay. Then we've got fetch user by name. Which also does a Helix users, but responds with got users by name. Okay. And this might be extractable. So state for event. This is sort of like expect. So we're going to have a decoder of a function of A to we know it's going to be an app message. We might be able to make this generic because it's not going to specifically, no, it's going to specifically mention HTTP error. And it's going, oh, you're going to need the model if you're going to do an update. Or we have to return a function of model to command model. Type signature wise, I could do this either way. Do either of these make... Oh, we need the actual body. About that. Oh, and the state. So it's generalizable but painful. Now this is where, well, for the tagger itself, we can do that. I'm currently having HTTP error take the state. If I didn't do that, I could curry that into the tagger. Let's maybe do that in a separate step. Yeah, this is... We need to work on this. I could probably stop this at the message level. As much as we will be sending a update with this always, we have to pass through... Oh, I guess we'll only have to pass through model. But that's really what this function's doing. We're going to have to end up repeating the update model, update model, update model. All right, does the function stand by itself? Does not. Okay. So taking state out won't be enough. Well, that puts two strings next to each other. That's kind of our argument order. Is this even enough to be worth it? Right. Well, I could have you be curried. And we just have to have state for HTTP error. Maybe this is a good catch for later. Ah. Okay, so that decodes by itself. So we want to do decode response function signature a mile long. And all of this has to be an update model. I could perhaps set this to like return a function that takes some of the extra parameters. It's sort of, well, that's just currying. All right, and then any one of these should be sufficient to test that. I mean, other than putting the wrong things in here. HTTP error. Do we actually use our state? Yep. Now this is interesting, because we only use it for the auth failed, which is never going to be a bad body. And you should probably be sending an error response anyway. Well, I have in mind ways we can deal with this in the future. Then I wouldn't be dependent on passing that around. We could have decode response take HTTP error as an argument, with everything pre-curried. Because all of those types aren't dependent on the A here. We just have a dependence here that we can't have a function that returns like only our decoder, or that handles all of our mapping functions. And if we didn't, if we did the update inside, we'd just be passing model to this function, so it would really only save us the update word. Now we have technically gotten a state here, which means we have a session, which means we could send a response. I think we want to do something different with that. This has been a step in making these general enough. We could maybe think about how we deal with this. Now, my problem might be how do I handle the expects? Well, it's a type of expect message. And maybe I have to make that a application specific type. I can kind of switch off of the internals. Result error string to message. Well, so that's a string. Expect JSON with a decoder. So that is a result with a decoder to an expect of message. The problem is that in real Elm land, rather than magic runtime land, this expect is actually parameterized off of these things. We're just pretending that it's only parameterized off of the message. I'm pretty sure. Can we write that function? All right, we need to commit first. To be able to store something like this, we have to have an expect message type, and the rest is all standard stuff. And we have to be able to write a function like expect JSON Hey, Andrew Twitchy, how's it going? That's a result message. That would be our tagger. So, oh, actually, this has it in the other order, too. Point to consider. Wait, that's a result error. Elm is a compiled to JavaScript language that is more in like the Haskell or ML tradition of functional programming with immutable state and a type system. So in pure Elm, you pretty much never get runtime exceptions. Now, you often have to integrate with some JavaScript, which might still do some things. You can still have errors, like you got an HTTP response you didn't expect, and because it's strict, you always have to deal with things that would have been nulls in other languages. And it might be a maybe type where you have to explicitly handle both cases, or a result type, which we're considering here, which has an explicit error message. It also means you have to satisfy the type system, which is something I'm trying to understand if what I'm dealing with is something I can write, or if it's something that's kind of a special case in the runtime system. Actually, this doesn't have to have data, it just has to be a type. This would be a decode error. Okay. It's typable. What would this look like then? Babel, you mean the higher version ECMAScript to lower version ECMAScript compiler? In the sense that it is a transpiler, yes. Yeah. The newer versions of JavaScript have added quite a lot of stuff. So it's almost a different language. I guess in that sense, yeah. It's just the language is more different. So the primary target environment is browsers rather than Node. You can do some stuff in Node, but most of the libraries and a lot of the nice sort of stock behavior is built around browsers. So like you've got a HTML view system, which the thing I'm working on right now doesn't have a view. I should probably just view. The app, this is a backend for, which I'm purposefully doing something hard as a programming exercise and trying to use it in a Node environment, is a browser model. So you typically build things up. I'm doing a little bit of extra stuff with CSS here, but some people prefer to do more code Elm-centric styling things. This is one of my older apps, actually. So you typically build things up with these code statements, functions. So it's a little bit like React in that sense. If you do like kind of more like pure React without the, I forget the XML and JavaScript the technology is called. Or just functions, you give them attributes and other elements, functions as, a list. JSX, yeah. So its view model is very much like React's in the sense of, you pass some data in and that deterministically creates a like AST of your page, which the library translates into HTML with virtual DOM diffing. This is actually doing SVG, so there's not a whole lot of HTML in here. All right, now can we write this function? So what this would do, well, it's creating an expect, so an expect would have to be interpretable by us. To do this, what we cannot do is write it like this, because this is a type. So we'd have to specify the types. The types are these. And that has an A in it that is not in our parent type. So it cannot be that. Well, admittedly, we're not, or is this just, yeah, unbound variable type definition. So it didn't even get to here. So we would have to be able to render this into a function that was a decoder of message. Which now it wants an argument. So can we write that? This, we have a function that takes a result. Now, this is already a result. It is either a decode error or an A, and then we do further decoding on it? No, that's a decoder of that type. No, we run the decoder, we get the result to message. That might be just a decode.map. And it's decode.map the function. And that's a result. We have to apply the decoder to get a result. How about... Is it decode and then? We apply the decoder. And no, this only applies it if it was successful. I don't know if there's a result type. No, that's just A to B. So it looks like we have to run the decoder on something. Maybe this is not a decoder specifically, but a JSON value to message. We need to put a body in here. So now we would say we return a function of value. And I might not, that's not the return type. The return type is an expect message. I might actually be able to make that an alias if that's what it is. Of value to decode. Decode value. Yes, because we have a strong type system, anything that is a JSON, JSON in JavaScript is loosey-goosey, could be anything, could be there, could be not. Decoders are essentially a parser or a validator that says, check if that thing is a string. And if it is, return it to me. And if it's not, tell me that something was wrong. So these are, these are very, very primitive things. If you need to go digging in, you do a lot. What you do a lot of is field. Then you say field blah, which in your JSON is, x blah. And then the type of that thing, I probably got some other decoders. These are slightly complicated because I'm doing some string type switching. I don't know if I have terribly. There's encoder. Typical decoders here. Well, okay, this is somewhat typical. We've got a state which isn't in this thing, but it's like a 3-element structure. You say we're gonna do a 3-element map. There's another form of this. You can do any number of fields by kind of currying stuff down. So your types will generally give you a constructor that takes 3 arguments of those types. You say, go find the request field in the object. We're going to parse it as a request, which this thing does one of those big fancy switches again. Retry, which is just a Boolean, essentially, just a fancy Boolean. And this is a weird case. I'm essentially passing around a JavaScript callback as my sort of session to handle later. This is part of the thing where I'm using it in a very unusual environment, and I'm experimenting with ways to deal with that. But this is fairly typical for your JSON decoders, and they are one of those things that's kind of a common stumbling block for people getting into Elm, because it is a little weird coming from other environments. And it has this weird function signature. I did an exercise where I kind of tried to rebuild it, and you can kind of figure out that decoder of A is roughly, what is it? It is roughly a value to result error A. Which is actually what you'd expect, because like an encoder is functions from A to value. That's nice and easy to understand. And this just has the problem that it can fail. But the actual implementation is JavaScript in the runtime, which is like turning the decoders into a sort of AST and then running that. So it's not actually this, which will be a little bit easier to work with and understand. But if you need to think about it, you can sort of do that mental translation and try to figure out what's going on. Decode value. This is where we run our decoder. And actually, this, because of currying, we can just say that is that to a result. And I think because it's missing an argument, we have to use this one. As an incomplete function. Well, that's fancy functional stuff. Let's do this plain for the moment. No, actually, this is arrow for a lambda. We decode our value, and this is still the function. And then, so what you see a lot in Elm is, and then take that value to blah, 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 which in this case I think may just be our tagger, which could also be written as apply this function to that. Or you can do some local variables. We could say let result equals this, and then message is tagger result, and then in this case it would just be message. Or you could like get the one part and do that. So I would probably think of this as a two-step process. And I think you can actually write this as, we curry this, we say, okay, applying one argument gives us this function with one less argument, which you can kind of do in JavaScript. It takes some extra function calls. And I think when you do that, we have to do this. And that's easier here. Frankie Mixter, thank you for the follow. So this is only a function of value to message. Oh, but this is, no, this is not just this. This is going to be result. This is a result. Well, given a function is actually result to message, that would be correct. Okay, and a thing like that would so these things have been, it would look a little bit more like this. This is not the standard library stuff because I'm in this weird environment. If we look back at source, this is the web end app, which is going to have a more typical, so it would be a thing like this, that would be that tagger function. It takes a result and it gives you back this message type, which is any one of these things. So on this end, it either was successful or it was an error. And I usually handle these by expanding these in the case. You could also say videos result and then do a switch off the result and handle it there. So that tagger in there is going to be your message function essentially. Where do we use that? Yeah, so this is the thing I'm trying to emulate in the standard library. So it gets that message, which is going to take a result, and it's going to be my decoder. And I don't know if this is something that can be expressed in plain Elm or if it's relying on some sort of the backend library stuff. So I'm trying to figure that out. Expect JSON tagger decoder equals. Oh, no, we compiled. So this does appear to be expressible. As long as that type is all handled sort of inside of here, we can actually express that this sort of, this is a value to, oh, I did decode value. Same thing as decode string, I believe. Yeah. So our expect is just a string to a message, and then back at HTTP, they've got a couple of expects. So this might just be a straight up pass-through, more or less, as long as we got a actual string, or we got a body. Yeah, maybe you do like a JSON decode string on it just to make sure it's a string. Something like that. And then JSON runs the decoder. And then this is binary data, which might be a little bit more of a special case. Thankfully, I don't have to deal with that. That would change this. What we could do in that case is say, well, okay, so the formatting is usually a little different. You say it could be a expect string or an expect bytes, which is a bytes.decoder data. I'm not sure what the type they use is. Oops, this would be an a or. So then you would have an enumerated type, and then this function, of course, would have to. Well, this is expect JSON, so it would return an expect string. Or maybe it actually is an expect JSON, and they do something. They do a special case there, because you could also do an expect. You actually do this as expect string. It's just a string, and you actually do this as expect JSON, and then this would just have to specify that constructor, which takes that particular type, and then the thing handling it works with that. In my case, I'm only dealing with JSON responses, so we don't. I mean, we could put the expect JSON in there just to make things expand nice. So this type of thing appears to be expressible in plain Elm. I just have to make sure I can construct things around using these kinds of types. So this is a tagger and a decoder, which, what do you know, is two of the arguments to that function I was doing. And since I do only have one of these right now, it could actually, I could just make this a type alias. Oops. Have a little bit less typing protection, but it can be easier to deal with in cases. Now, we were following on the standard Elm one, which is result. Well, that's the result of running the decoder. Now, the message we passed down there took a result. And it said we had a decoding error So I've handled this in some of my other applications by just having, instead of my message, I have a little wrapper around my message that takes out that error case and turns it into bad body. Which maybe we can rewrite some of our stuff into. So we had decode response. So we could reconstruct this around the expect type to combine two of these things, which they did in a different order. But to be more standard-like, which is kind of what we've been doing as a first stab at how all this works. And maybe in my version of this, we actually need to have some of this other stuff in here. So then you would take, rather than these two functions, you would take an expect of message, because this, we've explicitly mentioned a type here, we have to know what type that is. So now that has the decode string, and it passes it to a thing that handles the result. So this is an expectation. So you would be wise to what an expect is. So we would I guess for expandability, we do this the dummy single case. Even though we don't actually need that expansion right now. Expect dash. I don't know what to call you. You're a string to message. Or kind of tagger. And then tagger is a function which takes our body, and this gives us oh no, this does not work for me as is. This is where I have to wrap the error handling up at this stage. Or maybe I have another function that, no, okay, so first pass. What was I calling this in the other apps? We called this HTTP response, which we passed oh, that's the helix level tagger, which takes the place of the tagger function. And maybe that could handle some of the state and stuff. So this is getting more verbose now, but I think we can eventually pull some of this stuff out to a more general level. So HTTP response. Oh, and you had the tag for the error cases, which was the only reason we had to pass a tag here. So that takes care of part of it. And this one could potentially have the state. And that is indeed a string. So does Helix an expect string? It's probably an expect. Oh, that's the tag. Yeah, and then our real tagger, and this is a straight up. And the result we got. So that's the piece there. Here's our HTTP error. And I had a generic response type here. That might only be in this app where we're like doing some generic handling. So I probably don't need to worry about that part. All right, so your HTTP error is going to be different. Yeah. So now this does in fact need the state to be able to construct an error response. In this version, that was also the only reason we needed the state. No, we passed it there, but we don't have to. So if you have a tag, well, we did state source, so yeah, no, don't need that here. So this is actually taking over most of this. This is actually pretty close to what that was doing. This had success as an ordinary tagger. Where was I using HTTP response in this? Oh, HTTP response says, given a result, I give you a message. So this gives me the result version of the message, but whereas I'm passing this thing a success-only version of the message. So actually, I probably could have translated this to HTTP response internally and then not done the calls up there as a first step. So tagger on body. All right, I actually need this stuff. Well, I guess I could split. Yep, another HTTP response. So you are a straight up, no, expect is string to message. But internally, yeah, that the HTTP response gives me this function, the result to message, because we query everything up to that point. So you're an expect, tagger body, expect JSON is Body is the string. We apply the string, we get a message. The thing we passed into expect JSON was the HTTP response, which takes care of the result switching. And this ultimately results in there. So now this does not need state or tag. Actually, what response expect to body? There's probably a version of that where you can combine those easily into one function, but then it just takes a bunch of arguments. And maybe with fewer arguments on this, that then makes sense to push the update back down. So we said our HTTP response needed to have the state so it can generate the full HTTP error for this app. And then, so we already took the tag out, so we lose that, lose that, lose that. Unfortunately, the argument order on update is such that the message we want is the middle argument, so we can't easily curry that down. This is like HTTP response to expect JSON as the message in the decoder to expect JSON. Which is the middle argument to decode response with the body. If we took body to, well, decode response of that, so it's not a nice pipeable thing. It's like decode response of this function on the body. So we don't have we can't do a nice little pipeline where we say, okay, take the body and do some steps on it, and then do some more steps on it. Which would be something like run the actual decoder if that doesn't work, then we're doing this result switch. Yeah, we turn into result mapping, because once you're in a decoder, you're into that space. And then if it is successful, we run the tagger on it. But I'm not sure that would be typable in the generic way that the expect is. Because, let's see, so the expect JSON includes the state so the error can handle it. This is switching the tagger and the so we could do a switch for the expect gives us a thing that we could return from a function. But we have both the state and the tag in there. Well, the tag would be the thing you'd switch off. The state... You could make a last argument that could be added onto it. It would also be a thing that you might be able to store somewhere. All right, this is not an app level type. All right, expect JSON was actually there. You're used up in this place. Oh. Oh, I copied an HTTP error. So we've not even compiled this to see if this all runs. Yeah, we made a type for that. That's an HTTP error A. I'm not sure mine was variable like that. The success function expects one. Oh, okay. So we would have to pre-query state for this to work. So for the time being, we're back to this. Result HTTP error. Expect JSON. So in the old environment, HTTP response was taking the response from the HTTP library. And I need more water. I'll be back a little bit. So this is the most effective I've gotten one yet. Was not able to avoid using...
This will take a little bit, but it's important. Base won't function without it. I really do need to make...
Oh my god, oh, it's you.
This system is great.
I just tried shooting an arrow.
Can you do it again? Oh. Are you?
I had one, I wanted to get rid of it. There's a guy up there.
That was perfect gameplay right there. That was perfect. No one clipped that.
Clips anyway.
Shut up, Smash. There's some...
All right. In the environment we copied this from, we were getting a response from the HTTP library and centralizing our error handling. Oh, I may have deleted the code that was doing bad body. Yep. Which might in fact become this. Wait, my error. That might be taking over this a little bit. Because if this is the, well, what this is doing is specifically to code string. So I have glued these together in a little bit of a weird way. This was originally taking a response from the HTTP library and saying we're going to stick that in HTTP error. What I lost here when I switched to this result was actually the thing that detected bad bodies, which is like kind of one layer in from, or a hidden layer within the HTTP library before. We're not currently passing decoders to that thing because it doesn't have any way to associate messages and responses. So this may have to be given a decoder error, which is what expect.json can produce, unless we could do an error mapping. Could we though? We can error to string. And bad body is just a string. Where would we do that? So expect.json is decoder. The way we're gluing them together, this is definitely, if we copied, well, I saw error. I thought, oh, it's obviously it's a decoder error. Error here is indeed an HTTP error. But a decoder is going to produce JSON errors. So this thing is going to be a result. I want to reformat this here. Result.map error. If it's an error, it's going to be a decode error. JSON decode error. So that makes it a string, and then we do bad body, which turns it into an HTTP error. And then it should be passable to our tagger, and it will match this type. Value is a decode.error to HTTP error. To be a string. Oh! You know? I was only doing this for emulation of their library, but like, yeah, it's a bad body, so it's a JSON error, right? Expect JSON value is a string to message to expect message. A message to C. Expect JSON is a function from a string to message to an expect message. That's what we typed it as. We're trying to put that into a message to C. So this might actually be an error with what we're doing with HTTP response. Yeah, no, this is the declared type. If our type is wrong, then that would be its own error, right? Compiling. Okay, there's no type mismatch here. Expect JSON definition. The body is string to C. The type annotation says, okay. So there's a weird C in here somewhere. Does map error do what I think? Result XA, result YA. Parse int. Right. Parse error has all this stuff. We map it to just the string. So the type should change. So something's... So this is a detected type. It's saying the error is... Well, if it's saying this is the right type and this is a message to C, that means that tagger... Where does the value come into you? Let's take the types step by step here. produces string to result. So that should be an expect JSON. Expect JSON is a thing that we mapped from a string to message. So that's a string to a decode error. We want that to be string to HTTP error. Okay, string to HTTP error. The body is a string to message. The type annotation expects JSON, so it should be an expect message. Now, string to message, oh, maybe I'm using the wrong... Right, that's string to message, so I probably don't need to put it into this particular pipeline. Actually, it's probably the wrong format for this. Okay, that works, but I think this pipelining that is a little weird. It might not be immediately obvious that there's an operator switch there. I mean, even though it kind of follows that, okay, this thing produces a function and then we wrap it up there. And that took care of our bad body. Well, that was hard enough. I might be able to do some more... What's our case here? Oh, they're only doing this on OK body right now. So we're not handling what would be an HTTP response error of any kind. In fact, the only HTTP error we're processing here is bad body, I think. Well, this was a big enough change. Well, here's the other fun thing. HTTP response is our tagger. So we've now got our state in this thing, which is just an expect, which has a type that is theoretically storable. Well, it's all closures, which is maybe not the recommended practice. But obviously, the real HTTP library is doing things that aren't quite standard. We don't actually do an error response here. This allows us to have a function that is just the expectation. Of course, it needs to have all of the things that get passed to an expectation. So it needs state. I think it's just state. HTTP response can return a definite HTTP message, so you don't work for anything. Oh. We have to be able to express this case, though. Unknown expect. So this kind of like makes the alias a maybe, I guess. And then you. So what the heck do you do? So this would kind of be a bad body. Well, it's more of like an unknown message. You claim that you will return a message. However, you do not have the state and stuff. Well, okay. Okay, so actually don't need tag. We're not using that in this message. Oh no, source was the. I guess I could put like the error. I could actually put the expect error message in here. Which is and the error is. See, bad body was a unexpected or a JSON to code error. There's not a code error. This is like a. We got an HTTP response for which there is no known There's unexpected HTTP response. Error. What is HTTP error of? Is it an HTTP error for which we have no response? And there's nothing equivalent. Bad URL. Yeah, you just assume that thing can, that such a thing can, that an unknown response coming back can't happen. So I mean, we could just debug to do somewhere and say, well, you've got a really bad problem, buddy. And we've got state and tag in there. I think we've got a generic switch for unhandled HTTP errors. I didn't put any parameters in you. And it's not a very generic solution. Oh, it is unknown response. I put a string in you, even though there's really nothing else to say. Probably unknown response tag would be the thing if we could kind of get that out of the system. But HTTP errors always have a tag for what error we passed in. This is an error that is actually sort of from the runtime system and not. We've got some level mixing here. Or we've got our expect system has to return like errors in the next level up. Okay, it still works. I never actually called the code. HTTP expectation, state tag. This had the decode response, body, and update model. And like all that stuff kind of ends up at its middle argument, so it's not a nice flow. You could do body, decode response, then you have to wrap update around it. Right, expect error. What did I? Is HTTP? No, it's HTTP expectation, which is on the response side. If I get to the point where I'm sort of putting this into a structure, ahead of time, we probably won't have to worry about doing that by string. I can't put it in the state because that's a function which is not serializable, which is why they say don't put functions in state. Huh. We're down to 2 places, and those 2 places are, in fact, just 2 different cases of the result response there. If we pulled the other OK error in, we could conceivably do that once. So there's a couple places to go from here. One of them is with each type of HTTP request, our state sort of becomes a statement of the facts we were requesting. And then when we get that back, we match that up, or we keep around the states locally. getting rid of some of the weirdness of the state system, I think, is going to require doing that, even though that makes me worry about things that go off into La La Land. And then rather than trying to match one-to-one, we look at that statement of thing we were trying to request, and then that response applies to anything that matches. Could be a little bit weird with overlapping requests, but we're kind of treating all of the things we're doing as, semi-cacheable. Maybe not cacheable per se, but within the period it's in memory, it should be relevant, or should be the same. We're going to end up caching it a bit ourselves anyway. So like request a username ID, we can match that up by the username or the ID. Actually, you could match the user responses by username or ID if you've got it. Why don't you get back the username and the ID? You could then answer both. And we do an update process on anything whose facts match that. That's nice because it's a little bit more of a fully asynchronous request response. We're not trying to tie things one-to-one. That will involve storing the callback values, which we're already doing for temporary session queuing in our model. Just on a longer term basis. The other way is that we have like HTTP request IDs. So we still store everything, but with each request you have a outstanding request ID. And then HTTP responses come back with that ID. Which is more generalizable. Well, I've already got cases that aren't one-to-one. I guess you just don't have to use the information. Oh, right, because if we're currying like an expectation, then the ID based would get us to a particular function that responded to that thing. And then we call back to get back to a message that does some stuff. If it is, yeah, because we have to be able to decode our facts. Well, we're currently decoding our state. So it would be a thing like the state we've got now. We'd still have to be encoding and decoding it to say what it is. So you would have one level that was like in-flight. You could do both. You could have in-flight requests, which would encode in Elm the closure with the information about what we need to match against in our outstanding requests. Rather than the actual request information itself. I guess the one thing I like about the sort of request ID matching is that if the same thing got requested twice and one of them got lost, any response that came back would clear out both. So you'd have some potential for junk cleanup. I guess you could still get a denial of service attack by somebody just requesting tons of things. But if it was a list, I could just kind of truncate things if it got too big. Oh, you know what? Right. You're also doing some decoding stuff. We're not doing decode state, but we do have an HTTP response up here that doesn't have a useful state. And everything else assumes like HTTP expectation takes a state. Decode response has it in there. HTTP response state for event. So this is on the front end. I don't think the rest of these are relevant to our response handling. So HTTP response and expect error because HTTP expectation. So HTTP expectation and HTTP response. HTTP expectation, which uses HTTP response. So if I get it out of here, I can maybe get it out of there. And there's the expect error version. HTTP response. We pass state to both. We can get it out of the success case by passing that explicitly to the parent tag. That exists in HTTP expectation, though. And you've still got HTTP error. This is why we have the two-level system. For certain requests, you match. The other is just ID. Here's what to do when it comes back. That's kind of what our tag is doing. But then we end up string matching. I mean, we'll still end up matching, like, even if it's an integer tag, we'll still have to match it. And maybe nothing happens. So you use state for the session on HTTP errors. Is that all? That's all our HTTP errors, huh? So unauthenticated, and if this has a session, it should really respond. So what would a generic HTTP error look like if we were doing fact-based matching? It wouldn't be... I was thinking it could be request-specific state. But if we get back an error, we still need to know what to apply the error, which things are now unanswerable because we had an error. I guess we only need to know what we had requested. So either a fetch videos or a fetch user, which could apply to anything that had that user ID, or, well, you still need username and user ID because you can request with either of them. Maybe you can reuse one of those things. So doing a generic like request ID would save us encoding and decoding state. Because we'd attempt to find the state. And you would either find, and then you'd have a maybe instead of a result. So this update doesn't care about state. Oh, got token takes a result, though. And that's a Lambda HTTP error. We could probably at least, since we had to unpack the error anyway, map it into mine. And the reason we couldn't do the HTTP error message is because there's a state there that is assumed to be fully parsed when it's not relevant to the token request. So we're almost like this application needs to be back to the non-generic HTTP error handler, or each thing gets a result, because for like every type of, got videos, got user request, you would have to go through and reject anything that had a failure. And that would allow you to keep state-specific facts. Whereas, since the message is going to be partially applied waiting for the result, you can't dig it back out to figure out what it was. HTTP expectation. And if we come back into these generic handlers, we're going to attempt to decode state. I mean, I guess I have a state for token, and then it's okay, even though we don't care. We have a request for fetch token. How does a retry work? We update the state with what it was doing. And append state does a step. If a token request failed, well, right now it's its own message, which just fails us out. But step says if we're unauthed. Yeah, so that makes the fetch token that would be a new fetch token, which would then have retry yes in standard form. Well, if it's just no, we only handle this unauthenticated anyway. Now, that could indeed fail with an unauthenticated. And it would be unfortunate. Oh, you have a parsed, well, state.session. So normally fetch token doesn't have a session. It's more of an app level thing. So in order to make you a valid state, we'd have to do said dummy value in there, which might get passed back and executed. So what does that look like? We have an HTTP request tied to an ID, which is tied to an expect function. We try to generalize HTTP error. In order to cancel out anything that had matched the facts associated with that request, you kind of need to. You could do a state decode to figure out what we knew. If you are also keeping the states locally, you just do state equals. Or maybe single HTTP centralized error response is not good for this type of app, but it is good for the authentication error handling. But I also need to know which kind of request failed. All right, model, we've got pending requests, which are things we want to actually send out. When, in this case, when we're fully authenticated. You know, not asked. I mean, we could even work that into our retry state. You know, not asked, should retry, should not retry. So we have those. They get authenticated. We go do all of the not asked things and update them. It would be great if we didn't have to serialize state. could have a generic HTTP system that was ID to expectation. Is there anything else that we would want to keep? Request. Headers, URL, body, expect. Well, timeout tracker. If you were doing that. Yeah, I've never met with cancel and track. Try to cancel. Track string. Using string as kind of a generic ID type. Cancel based on a tracker. Okay, so tracker is used for both. It's just give us some string to use, which is pretty much what my tag is doing. That's for calls into outstanding requests. It's not ever replying with that information. It's discerned to be handling by the currying stuff. So we would make a request. We would somewhere record which would be a model update as well as a command. Somewhere record like some sort of ID number. That would go into the Lambda field, similar to tag, perhaps replacing tag. The thing we kept about that could what? You could handle retries at the HTTP level. You could certainly keep that information there if it came back. If you kept all of the stuff that went along with the HTTP request, which actually, what would you save? You'd have your expectation. Well, it'd be like URL and everything. Although that, oh no, that retry is authentication update, so it's not just resend. You actually have to repair the request again. So when it came back, you could look up the function to call, which would be one that received a result. Command, command, command. Event decoder. HTTP response is a string and a result. So that's the Lambda result. you would have an expect to apply our decoder. That only produces bad body right now. Well, you would only apply the decoders in successful results. That would kind of become HTTP response ID. I guess outstanding requests would be like a dict. So if something got lost, you'd have the outstanding request in that table. There's clearly a timeout mechanism. Somewhere in Elm. I'd almost have to set up a dummy server that never responded to test it. Most anything would just give you an immediate error. Is there like a... Yeah, it's all test run. Session timeout. Maybe this is like XML HTTP request. Yeah, I want like the... I just have to make a little tiny node server or something that just never responded. And then do a short timeout. That could take care of completely lost requests. Or even just record a timestamp and periodically clean them up. But what we record would be an expectation. So I would have to arrange to have the thing that received a Lambda result that would be a message itself to somehow match up what it was. It's an HTTP error, a string. And that's all these things. How do we know what you're associated with? Yeah, so this is actually creating the expectation when we get a response. It's not so much an expectation. We actually want to do that, so we're creating the fetch functions. It would go up a level, it would have to get stored somewhere. Matched up on response. If we get back an error, we want to centralize handling so we can do authentication errors. We also want to know specifically what failed so we could clear out outstanding requests. The nice thing about passing state around is that if you just stop handling the series that has that state in it, it just disappears. No garbage around. If you keep the outstanding requests around, you do have to deal with that, but that means doing the whole encode-decode dance. Does that mean each state has to have a... Well, I'd kind of like to have two levels. One is just we can associate a tag or callback with a response. And the other is a very specific thing. So I'm not using, in my HTTP response, I'm not using a response wrapper. A response wrapper could handle the authentication errors and still pass a result to the underlying thing. Which could take the error and what? Well, it would be all of the got videos, etc. would have their state carried into them. But then that would be handled by the general expectation mechanism. And if they got a response, they could say, well, okay, so here's the thing we got an error for. Of course, that's kind of almost back to the state threading. It's just that it gets handled by keeping an Elm structure with a state instead of encoding the state in a generic way. And so downstream of a decode is the only time we can deal with send response. There's that update. Well, that update also has to handle that message, which gets us, which currently has a generic state thing in it. We don't handle it at this level though. It's passed down there. It's assumed to be a session at this point, but that would be specific. We specifically encode it for that message in that case, I believe. So it would be, oh, you don't handle like startup. New event. Oh, right, because that's that session. And this is where we first work that first thing in there. That is event. So essentially, these would all be user ID session, username session. This would just be structure to function translation. That would lose the value and just become an event to state. So that gives us states for these things, which all right, so this is the event handling from Lambda, like level 1 translation layer. New event. Goes back to there. Just get appended and executed. And we might have to do things more like this. So we've got authentication specific, generic errors. Maybe it would make sense to do a separate event there. Because there's actually, maybe there used to be more shared there. Well, they're both using fetch videos, but we have to do something to change out the response event. Those can make more assumptions about what's going on. So these things would keep state. we could have, it would be, I guess it would be a generic response rather than HTTP error specific. Well, there would be some kind of generic response handling. So we want to pull out that bad status and see if there's a way to retry. If we're currying the state in here, and how do you get that in the error response? Well, maybe the fetch functions. That's state. Already take the state. Now they're currently encoding it into a special field in HTTP request that sends back to us. If we have the fully working expectation system, which you might be able to bootstrap this by having a little wrapper that saves the state and all of this stuff or whatever we need. Does the sort of ID mapping thing. It keeps the tag locally. I can kind of bootstrap that layer. That would push the state management out to more the HTTP layer. If our fetch requests saved, maybe we only save states that are outstanding requests? Oh, the question was, and then if this wrapped the actual, got videos or whatever in a response thing that had the state. That could be provided wherever it needed to go. But you'd come back response with state and message. And you could either go to generic HTTP error, which we might have to rearrange to put the state in the appropriate place. Or I guess you would have to then apply state to the success message. Let's see. So the state you passed around might actually be a request. Only instead of the full state. Then you would keep around the current requests in progress, or as full states in memory, and then you would pass the request type only, because you could go and match the request type with any outstanding states that had it in order to get the session to respond to. Anything to say here? Not a whole lot, no. And what did we map? We mapped... Yeah, I think this is... I was kind of worried this might be a problem for an entire stream, and I think that it is. It's about lunchtime, and I did see their Elm stream on. So that's going to have to be it for now. Thanks to the subscriptions. Thanks for all the hosts. Actually, don't think I need to look that one up. That's about when I'm usually on. And, oh, I need to get that up for myself, though. All right, but that's some cool stuff. Some more Elm code for somebody's cool to hang out. Thanks for hanging out with me. Goodbye, and until next time.